one. Fight! You lose. Round two. Fight! You lose. Round three. Fight!
Hello everyone.
Wow, whispering are we?
I just woke up.
From my eternal slumber.
I just woke up and I saw a vision of a simpler life, a simple registrator. Hope you're doing great everyone. How are you, Sir 3K?
Really great. I
Yeah.
went home for a quick little play session with the cats at home. Make sure that no one has killed another.
Nice.
Nobody has broken out of confinement today.
Good. Hannes is on paternity leave to mix and match a wild horde of cats while I'm trying to design a simpler marble machine. And the subject for this stream, everyone, is the registrator. Let me jump out of the sketch and you will see it in all its glory. Because we're doing something kind of fun. What we started this morning is that we are putting the registrators... where is it? I'm making one channel. So I'm doing the marble gate. I'm doing one vibraphone node right here. I'm doing one row of the programming wheel, and I'm also doing the registrator that for some reason isn't showing here. That's typical. That's some kind of glitch. And I just thought if we go to the sketchpad, I just want to show what I thought we were going to do in this stream. So I was thinking I think it looked kind of complicated over here. Like a lot of parts and it's thin and stuff like that. And I was like, can't we, isn't this actually the timing critic thing as well? So I had this idea that we could maybe move this adjustability. So first of all, now we're trying to make a faster gate, what people call a speed gate. And first of all, I think if the programming pin comes like this, I think we should have a thinner thing, something like this. And then I just envisioned the simplest little thing ever over here, connecting to this. And then, but over here, that we would break this red thing up and have a screw here and kind of move this back and forth here instead. So we don't have this whole complicated adjustability over there. And I got super excited because I thought this is much simpler. But I just realized that for travel length consistency, I don't think we would get a little bit of adjustability because we could move it more here because we only need 6mm travel of the Bowden cable, or throw, I think it's called as well. But I realized that we want this to flip very fast. We want very fast, a very small interaction with the programming pins. And we're not going to get enough adjustability if I do this idea. So 20 seconds before the stream started, I realized my mistake. And I realized that we have the right idea from the beginning, actually.
Yoshik V2Mane. Let's see if I can just hit his comment up here. I had this idea that you could attach the Bowden cables directly to the registrator's pendulum arm and move the mute system to push on these arms to the play position where they don't get hit.
I had this idea you could attach the Bowden cable directly to the registrator's pendulum arm. So I guess here to put a Bowden cable to that arm and move the mute system to push on these arms. Yeah, so the issue here is half hits, I think. I think what Yoshik is suggesting that move. Yeah, it's hard. If you have a sketch, let us know and send it to Dropbox. I think you mean to push them back. I don't understand actually. But please send a sketch because it's interesting.
And we have fans literally everywhere, like Mastar 15. Hello, I'm in a queue in Primark.
Nice.
Tuning in straight from the queue. Don't want to miss a thing.
The Primark is enlighten me.
Isn't it like a shopping mall or big a store, right?
Ah, cool. Primark.
Yatagaras trött Hannes. Inte det minsta faktiskt.
No, we're ASMR.
Yes.
That's
and the thinking oil is right here.
So we're going to I'm gonna take off this Jon Snow thing. We're going to
Mr. Gonzo. Also the cable would be constantly pulled. Gonzonator.
Yeah.
Yeah.
So let's instead think that we're gonna keep this system, but what we have to look at now is that we have to look at throw or cable length. Nice to see you here, Gonzo, again. True engineer. Because this gate needs to be pulled 6 millimeter. Oh, I have a surprise. I have a Bowden cable.
Oh, say what?
Should we go to full screen maybe? I went into the local bike repairer and he just went behind the desk and was like, because they are like a consumable, right? So he was like pulling this out of kind of a thing, a plastic bag.
A thing?
And friction is great. It moves super easy. And like I tried to bend it 90 degrees until I cracked the cable because it's old. So it's a little bit of a consumable. But I think even with some bending, this will work. Like I'm not, imagine these cables are meant to like so much force from the hand with like a person who weighs 80 kilo is like biking like 50 kilometers per hour if it's me. And still work. And I think for our application, 6 millimeter of this, I don't feel it it's like super, super promising. So I have a Bowden cable. So I think Bowden cable is going to be the thing. And so this Bowden cable here is going to move 6 millimeters. So let's think that this is the adjustability we're going to use. I have some ideas for here. We're going to look at that later. But now let's look, because what we want is that pivot that is resetting earlier. And I think I can move some of all this stuff above. Let's go to the sketchpad and I can just show that. So I want to make the pivot shorter. So I'm thinking I can remove all this on this side and just put it like over here somewhere. So we can have the spring like here and we can have a stop thing here. We can just move things up there. So to shorten this distance, because if we can shorten this distance, we can go back to CAD. We can have the registrator resetting faster since we're trying to make a speed gate. And that's what I started to work on here a little more seriously. So let's go into the sketch. And let's say that between these So the interaction, here's the interaction with the programming pin. So how much do we want actually to feel really safe? 4 millimeters is kind of small. Let's do 5 millimeters. The smaller interaction we have, the faster I think we can reset it. And this is the height, this line here is the height of the registrator. And then so now I'm gonna draw a line from here to this line, and this is going to be 65 then. Or because I wanna mess around with these numbers, then I should use a function. So I just hover over here, D770, and this one is D772. So this line is D770 plus D772, function 65. And then I want a driven dimension to show the travel at different points. So I pull a line here, and this is already set, but I can ask Fusion to make a driven dimension, which means when I make it, Fusion will say, adding this dimension will overconstrain the sketch. Choose OK to create a driven dimension. And I choose OK because I want to see these numbers. So let's see that we're attaching the pivot point a little bit higher. We have to calculate the travel kind of up here. And we're going to give this distance a function as well. So I'm not going to put 42. I'm going to put D770 divided by 3 divided by, how can I do that? Divided by 2, perhaps. That's half. I actually want like 3/4 out of D770. How do I do that? D770 multiplied by 3/4. Can I do that? Yes.
There we go.
There we go. 45. And then I take this function, and it's D775, and I do the same for this one. D775. This means that I can kind of only change this value, and everything kind of follows around. So let's measure the travel here. So this is interesting. This is 15, which is more than what we need. So either we can make it stronger, or we can make the pivot shorter. If the pivot is shorter, it's going to be pretty strong, pretty heavy.
I just want to put this up here that Mike Perry said. The Bowden cable is designed for curves, not bends. So as long as there are no sharp bends that will put the tubing at risk of breaking, you should be able to place the cables anywhere.
Yes.
Good reminder for everyone who are hesitant about the Bowden cables. They're designed for this.
So like things like this, I honestly feel almost no, I can do like this. We're never going to have to do this. I feel almost no friction difference when I do a bend like this. I tried really hard. That's when I cracked the cable to make like a 90-degree turn, and then you start to feel it slowly, but it's fantastic. And I don't think we have to go to the hydraulic ones.
I looked into the Dropbox folder quickly and look at those.
Yeah, they are super beautiful.
Compressionless bicycle wire housings by Nocon.
Yeah, I saw.
Ho 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 ho.
Yeah, beauty from Magnus Westerlund. Thank you, Magnus. And I think we have something similar on this. If we look at this website, they had, I think here. This looks.
Yeah, kind of like
same
that.
idea. Imagine how industrial that would look on the marble machine. Like the Matrix, here we come.
Absolutely. And this was also suggested. This combination of cable and housing is well known by the cycling community to be comparable to hydraulics.
Oh, wow.
And bonus, you get to pick which color housing you want.
Oh, that's super helpful.
Chris Berry.
Oh, this Bowden cable thing is going to be so nice.
Revolutionary.
Thank you. That's a very helpful screenshot there. So remember, we want a travel distance later on 6 millimeters. So right here, we are now up in 12 millimeters travel. And I think we should have a little bit more travel distance here. And then all the slack will kind of eat up. For example, there's slack. We need slack here. So we even have the sign for 2 millimeter slack there. Let's check what happens if we... Yeah, so the real important thing is to check physically with programming pins to see what's possible pin. Oh yeah, I'm going to do this. I'm going to make a pin line. So this line here, I know it's a little strange maybe. This line is a pin line. And then I'm going to make another pin. And I'm going to check, for example, so between these two programming pins, I'm going to start simple by doing 360 divided on 64. So here we can clearly see that this gate will be able to play. This is good news, actually. Boom, 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 boom. So I kind of confirmed here that the registrator will return, in time for the next cranked up. So doon doon do 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 doon doon do do do. Wait, that is good then. Doon doon do 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 do. It's good. We're good.
Yahoo!
Yahoo! This is because it's on the offbeat. Dun, dun. I will play other songs on this. Ja visst. Det är hur bra som helst.
Ja, där satt den. Du.
Den satt rätt
Upp i krysset.
Precis. Genius Mount think the same. So this shows me, let's try to push it. Can we play like 3/16th note? So that will be 360 times divided on 128 is going to be too tight. You can see here the second pin is exactly there. So we can't do we can't do 16th with one registrator, but maybe 3/16th. That would then be half of. I want to add half of this. How do I do that? Half of 64? No, that's maybe not true. What's half of 64?
32.
32. What's 64 plus 32? 86?
90.
No, it's 86.
96.
64. Oh, 96. Let's try. Oh, that works out. So this is... Okay, so this pivot would be great, actually. We have 5mm interaction with the programming pin, but we have only a 5mm high pivot point. And here, over here, we used... What did we use?
Just want some more reassurance here from Memeplex. Brake cables on a racing bike can get bent 90 degrees across the handlebars. It's a pretty tight radius. You can do it around a Red Bull can just fine.
Memeplex, it was thanks to your comment in the previous live stream that I actually, just where I've been living, there's a bike repairer next to that. So I just went in there, and it was because you said maybe go to I think it was you who said maybe go to the local shop. So yeah, Bowden, thank you for that, Memeplex. So here we can kind of throw I think this looks great. It's even more than we need. Yeah, this looks nice. But of course, then we have the length of the registrator to think about also as well. What I mean is the underside of the thing interacting with the programming pin, because if it's wide, it will take it longer to return. So this is, I'm going to start to work a little bit. How can I do this? It's always a little tricky when you're using old CAD and you're gonna redo it.
Your past sins.
Yeah, it's like you're paying for paying for past sins.
Blubber Bub. I feel like you're underestimating the space you can have between pins because you assume the drum is fixed in your sketch.
Yeah. The size of the drum is carefully selected from the stock size that we think we can use on the rotary CNC machine. So if you mean to go with a bigger drum, we're already pushing super hard up against the biggest limits, I think, that we should use because it's so heavy. So if I understand your comment correct, Blubber Bob, you mean that if we increase the size of the drum, we can have bigger space between the programming pins? And that's true. And the bigger the drum is, the tighter the music will be, because the faster the travel speed, it just becomes a question about unruliness. It just becomes so monstrously large. So
consuming us all.
Yeah. It's going to be the suggestion with the whole band inside the drum. But let me know if I misunderstood it, because we can increase the size, but it's the weight of those drums were crazy as well. Okay, I'm just gonna dive straight in and start dissecting this old thing here. Let me remove all this. It was not good anyway. It was kind of good for the time being.
It served its purpose.
Yes.
It's time to Marie Kondo that stuff.
Oh,
Thank
nice.
you. Thank you for the memories.
Nice. Nice.
Bye-bye.
So I made this straight here because I wanted all the things. I'm going to do this nicer now. Check this out. Think we're going to go kind of a straight line here. It's already looking better. I'm much less negative now, Hannes, around the project. What? Why are you laughing? Why are you laughing?
It's out of the blue here. That's it. I'm much less negative now.
Yeah, because if I can make my design requirements, if you saw the update about not having double notes on the vibraphone, if I can keep making those kind of decisions, we're in for a less bumpy ride. That's all I'm saying.
You'll be a happy fellow.
I will maybe be a touring fellow at least.
Oh yeah.
Which I think would be kind of fun. We actually had a meeting with a live booking label the other day.
Oh yeah.
Yeah, so they are start to talk. They are they are super nice.
The goosebumps you start feeling when someone mentions the future.
Yes.
Okay. What?
It's not. It's super fun. to think about, to dream about.
Okay, Space Noodles put it better than me, Blubberbub said. So, Space Noodle says, they meant that the drum continues rotating while the registrator is returning to the rest position, so you might need to have the pins further apart.
Ah, that's true. That's true. Yeah. That's a very good point. I missed that in my estimation. I still think we can play whole notes, which is actually fantastic. But I missed that. Very good point. So I'm gonna put this down 60. Oh nay. The wrong thing is jumping. Let's see what we can do about that.
Here we go. H. Warner. I recognize that name. Hi, just here and have to go. But I updated my document with some more info to hopefully help with modular thinking and block diagrams.
So this is thank you for being here, Warner. This is a fantastic resource in the H. Warner made me start the educational section of the documentation. So if you go to the documentation central, I'm gonna fix so you can see it here. So the document is very interesting. It's this one in the educational section, and H. Warner have been working on this. I haven't been in here. Wow.
Oh ho 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 ho.
And also because what you did so nice, Warner, is that you just gave you gave enough information but not too much. So this is super approachable for anyone. So this can be an interesting read, and the community has been collaborating on this educational document. I'm so happy about this. It's so cool. So thank you for letting us know. I'm definitely going to read this off or on another stream where this relates better to the topic.
Great. Thank you so much, Warner.
Yep. And for everyone else who's interested, just go in there and check. It's a brilliant document. Now let's see, how can I constrain this a little bit better?
Om G. Stav, seeing you on Göteborgskalaset both times, two of my favorite concerts I've ever seen.
Yay! That is super nice to hear.
Then you saw me as well then on stage on the second Göteborgskalaset show.
You were filming.
Yeah, I was filming. Ooh.
So this is 5. And now I'm going to take this measurement. I'm going to give a little more space so we can see what we're doing. So now I'm going to use the research we made to the left there, which was just a sketch. And I'm going to try to tell this pivot point to be 65. No, what did I say? 50? 55. It didn't want to do that. Oh, it's here. I need to take this away. Yes. From here to here. It's 95 now. We go down to 55. Boom. That's a short pivot. So let's scrap all this scrappy scrap. Oh, it's a super cute little pivot. Actually.
Okay, let's see. Yoshik V2 Mane. I just uploaded a simple sketch of the idea I mentioned earlier, so let's have a look-see on that then.
Fantastic. Both channels muted. Green channel muted. Okay, so you move it to that thing, but the muted channels will have, yeah. Yeah, okay, so I love what Joshik Vitomane wrote in the end. I decided to voice the idea mostly to add some new out-of-the-box thinking. And this is
Yes.
exactly what sometimes stumbles on, because this won't work, because every time you mute, you will play a note, and then it will be muted. So that's why the other muting can be muted without a note getting played by the muting lever, because the cable will bend. And I also think when you go back, you have the half hit, that the registrator on the way back or on the way up, that the pin can half hit it. But this is the perfect culture that I love that we're having, like that we're voicing everything, even though we maybe have already figured out that it won't work. It's still worth to put it on the table, because we might stumble onto something else. Look at this cute little fella. It's so small. Tick, tick, tick. We have to make sure that this doesn't go into the... That's an issue now. That's a real issue now. Maybe it has to be higher. Oh, maybe the screw can be moved. Maybe the bolt can be moved to the upside.
Kalle Liljeholm. Shouldn't pin distance be dictated by the design requirements? What I mean is that working from a fixed drum size isn't the correct way. The design requirements speak of BPM, but not about drum size or pin distance.
We have to design for manufacturing, and the plan for the stock material for the drum. I used standard sizes, and they are in steps of 10 centimeters. And I think just choosing something that works good in CAD and then realizing that you can't source it in the real world is also a problem. So you kind of have to input from several. So in the best case, you input from both. In this case, I think it's better to think about what kind of stock material we can use, the HDPE water tubes that I'm planning to use for the drum. And I think it's better and I think the size is okay. So it would not make sense to I want it 5 centimeter bigger, and then we have to order a custom extrusion from someone who has a contact somewhere, maybe come through like that.
Linus Öberg, I just cracked open a cold one. I think I need a Wilson. Cheers. Wilson Cam, pretty please, H3K. And you know what? I am not a monster. Wilson will cheer you on. Cheers. Cheers, Linus. Cheers to everyone out there.
You're not late to oblige.
No.
And regarding the design requirements, I'm going back and forth, and this is part of the process, because I also had this email about over design first, PBS later, and this is design requirements can also be visualized inside CAD. So over documenting in the wrong way can also be an issue. Like this machine is so complex that going too hard I think the whole design requirement thing is more to understand that is how a design process should be thought of, very high level. And then let the CAD actually become the design requirement, kind of.
I just want to see here. Lee Smith says, I just uploaded a possible alternative muting system based on something Alexandros said earlier. Let's have a quick see on that. It's fun when we have them live here in
I've
chat.
seen this before. It's cool, but it's half hits, I think. It's half hits on the way up and down. Like our system, the one we have, is solving for the half hits. That's the thing that is always
Always the half hits.
yeah, it's always the half hits. You can't have a state in between muted and unmuted where this little point here between those things. Our half hits is right on the point, and what we are hoping then is that it slips. So technically, we also have a half hit, but our half hit is so minuscule. So it's the half hits. Let me see here what I can do about this. Let me see what chaos will happen if I unleash. Let me take this away. Let me take these away. This looks better, I think. Look how tight this looks. Like smaller, more compact, more controlled. I love it. The only thing is maybe that we should move. Because this will bump down into the next. So the tip, I think, will bump down into the. Maybe not. We have to calculate that.
And as Yoshik V. Tumane says, wasn't this muting system the only thing that never failed on MMX?
Yes. It worked from the beginning to end. So we love it for that reason. I love this look, actually. Look at this.
Yeah.
It's much more
sleek.
It's much more sleek and compact. It feels like we can trust it, but we have to. So let's keep on pushing. Which one is this?
And Robert M. Stahl keeps typing meow here and giving me PTSD. I hear my cats in my head now. Just wondering. All of a sudden, the door will break in here and Pixel will be standing there.
The Velociraptor.
Yeah. Velocicaptor.
The Veloci something. So let me change the shape of the thing that is interacting with the thing. Like this. I'm gonna make it much smaller. No, not like that. It's raining on our window till. It's a beautiful.
Oh, it's so cozy.
Beautiful, cozy autumn feeling. I keep radius over 1.5 because I'm thinking we're going to use a 3mm cutting tool. So it would be even better if I could do 2.2. Can I do 2.2? So I'm thinking a little bit design for manufacturing when I make those radiuses, because if it's 2.2, we can use a 4mm tool. So this little thing is going to be should it be like 6mm wide then? Oh wait, 3 I mean. 3 there. And this. I'm getting a little. I'm starting to feel it. I'm starting to feel it a little bit, Hannes.
Yeah, you're way more optimistic nowadays.
Yes. What is that? What was that?
Referring to you earlier this stream.
I don't understand.
No, you're so cute.
Cute. It's like when you say that food tastes interesting. You know it's a backhanded comment. You just know it. What happened here? 14. Ah, so this isn't set yet.
Let's see. Space noodles. As the pin slides past the registrator might hit the pin on the way back, causing the pins and registrator to wear out, perhaps angle or curve the backside of the registrator.
Yeah. That's not a bad idea. We don't want this front edge to be too fragile. So, for example, but you're absolutely right. I don't want to make it sharp like this, kind of have a shape like this. But we can definitely fillet the backside here.
Yeah.
A little bit. So I just realized that this is not a center line. So I made my mirror pattern over a stupid line. I'm gonna make a center line from here. And then all this is wrong. Okay. This is my center line of the registrator.
Mr. Gonzonator, there will be a positive stop though? Question mark.
Yeah. Up here. We need it up here somewhere. I'm gonna use the top of the pivot for that. So positive stop here and like spring somewhere as well. Spring here. But I realized that the positive stop is not what adjusts the timing of the music, because this slack between these two parts, this little area here, eats up any indifferences, if I'm understanding it correctly. So as long as the positive stop is consistent, it's fine. I don't know if I make sense. So I'm gonna mirror this over the correct mirror. No. Oh no, my mirror line. Look at that. That looks engineering, doesn't it? Oh. So here comes a difficult question, Hannes Paradis.
Wow.
Should the bolt be down here? Okay, so now we have to check travel length, because maybe that will. So whoever said like rounding over, I think what we can do is that we can round this side pretty much. Not that much, but maybe like this. And then you should always have learned, when you're seeing something from 2D, you should always add a fillet. Even if you want a straight corner, just add a 0.3 fillet or something like that. It will make your part much better, because you don't have a burr and stuff on the sharp 90-degree corner. So with that, we can do the same here.
Ba-boom.
And it's also just easier for the CNC machine to make a turn than a sharp. So it's always nice. Of course, more G-code, and if you're worried about that.
Toby Williams, H3K. I put a picture called Bell Crank in Registrator Dropbox. Might relieve some of the constraints on the registrator. Let's have a quick look-see on that then, while you take a zip there, Martin. A bell crank adjusts travels.
Can we have a scene where we are like... How did we do that? What?
From your computer.
So this is... Okay, so we need a new scene.
Yep.
Because it's gonna be so nice when we pull these up full screen
yep.
and we come up there. So let's make a new scene because everyone. I'm so proud that you're using our template, and then I want to actually like show how we thought about it. Okay, registrator, manual playing. Okay, so we don't have manual playing on this machine. Marble gate. Bell crank allows adjusting the throw of the pull. Easy disassembling by being able to unhook the cables from the bell crank. So thank you. I don't really understand, and we are not going to have manual. It's not part of the design requirement. So, but thank you for sending the question. Yeah, it was a little hard for me to fully appreciate it, to fully understand it. So why are we... Here is better. Let's take these two parts, this and this. Which one is this here? I'm going to copy them, and I'm going to pivot them around the axle as if they were playing. And to my surprise, I think I checked that before maybe. You see, the front there is never entering the marble, the programming pin. So do you see how this tip here is actually staying above the line? So let's see where this would... There.
So let me try something quickly here, Martin.
Yeah.
Almost.
Almost.
We're getting there.
That's a nice one. Very nice. It's easier for me to see the suggestions like that as well. So this has moved 27 degrees. What did we have on this one? $23, so a little bit less. So let's now check the travel. Oh, the travel is pretty straight, which is interesting. So now I want to check this length, and I think it's too much. Which is, I think, a luxury problem. Whoa, 21.
Excuse me once again. Ah, yes,
oh, nice. Full screen.
We're getting there, right?
Fantastic. So if we somehow could crop in my feed, so we still have the agenda.
Yeah, that's my next step.
Fantastic.
I sadly can't do that much editing while we're
but
live.
That's beautiful, Sir 3K. So we have too much travel, which tells me that maybe we should change place of the bolt and this attachment. What would that result? Would that be an issue? How would that end up, actually? So let's go into the sketch again and find this out.
Yes, Gonsonator adds here, with that adjustment type, your radius from the pivot changes depending on the tuning position.
Your radius from the... Yeah, that's true. That's true. Not a lot, but it is true. So what Gonzo is rightly saying that since the adjustment isn't round, but it's... we looked at it and it is... No, wait. It's another effect. So what Gonzo is saying that when we move this back like this, Oh, did we have two? Hang on, to remove them. If we move this back like this, the travel is going to be less. That's what also turned me on to some kind of other. I have the feeling we have too much adjustability in this though. And also the midpoint is right under the pivot. So if we just do this and this, wait, let's calculate how many milliseconds this is. Can we do that?
Memeplex. Attachment point closer to the pivot point equals less travel.
Yeah, that's why I think it's cool to put it up there. And it also makes it stronger. It also makes it slower, which I kind of don't like because of musical timing. But wait, if we have that much travel, no. Let's go here. So 120 BPM equals 128 BPM equals 2 revolutions per minute. Which means...
Here's something good to pick up on also later here from Lee Smith. I'm unsure why this needs to be adjustable at all.
Yeah, so Lee, this is the fine-tuning of each channel, and it's absolutely necessary because by having this adjustable, you can any inconsistencies in the different channels, how they're sitting, any slack inconsistencies, any inconsistencies at all can be adjusted for. So meaning if everything is strict, imagine that the programming wheel is just off by 1 millimeter in one end. Then that whole part of the machine will be late. So by having this fine tuning, and I noticed on the Machine X, we get a fantastic control of each channel's timing. So it's to make the machine play tight. It doesn't have to be right here. We can think about having it somewhere in the signal chain. You could add this adjustability somewhere else between the registrator and the marble gates, but as far as I can see from here, this is the best place to add it. So if we go back to the sketchpad, 2 revolutions per minute. So if we do the 1 beat angle, 1 beat is then wait, it's a minute divided on 128, right? Calculator. 60 seconds divided on 128. Yeah, this makes sense. So 0.468 seconds is 1 beat or 5.6 degrees rotation. So then if we go to CAD, we can kind of calculate. So from here to here in that tempo is half a second. I was thinking that maybe we have too much adjustability. It would be so nice if we can make it less. Wait, this is actually here divided by 64. So 44 millimeters is half a second. 44 millimeter equals 0.5 seconds, which means that right now we have 20 millimeter adjustability. That means that we have 0.25 seconds range. So quarter of a second range. And yeah, I think we need that actually. So this right now is designed to be that we can move the timing a quarter of a second. And I think that's necessary, so I can't make it shorter. I think, after that little napkin math.
Joy to the world. The chime is back. And this is Paul Martin.
Hey, Paul.
Have you ever looked at using a gear wheel as registrator? That way it doesn't need to return and no clearance is needed. Thank you so much, Paul, for your contribution here and support. Let's head over to the main man himself.
Is that me?
Yeah.
Thank you, Paul. So that's a creative solution, but how would you attach this thing? If the gear wheel is constantly turning, how would you then attach this thing? So a music box uses a 3-point gear wheel as a registrator, but that plays the music box tongues right away. And thanks for the interesting question. If you have a sketch and how you would attach kind of the whole muting mechanism to a gear wheel, would be very interesting. You could probably push it and have it reset for everything, but I don't see it right now.
Mr. Gonzonator, why not build the adjustment into the pivot position? Then the registrator could be simpler.
Because this is what I actually want, Gonzo. I actually want one solid part. But how would that work? Sketch.
Here we go. Sketch.
So because you need them for all channels separately, you can't move the whole pivot shaft. So you need to do what? And you can't also if you rotate it, you can't pull this thing along. It has to be independent from this position. So I was thinking about this longer travel. Maybe we can just eat it up by having this longer. Let me think. Let's copy this part again. And I'm going to turn it until it's clearing the pin around there.
Mike Perry. I saw a previous suggestion by Bruce Pickett's that may seem possible about mirror flipping the part and milling a vertical slot for the adjustable connection height.
That sounds interesting. It's hard in text.
I saw somebody earlier talk about flipped apart. Can someone please explain a little bit more?
I think they mean, which could be interesting.
This is from Bruce Pickett's in chat here. Flipped apart, no more L shape. Then do a vertical slot that can be milled to adjust connection height.
I think Bruce draw the image in text. That is the first. This is next level, Bruce. So what Bruce means, I think, is this, like this. But I have to. Am I right here, Bruce? Is it this? But then in the correct place. Then a vertical slot can be milled to adjust connection height. Yeah, so we don't need adjustability for connection height. So we don't want that, basically. But the flip is interesting regardless. Let's see here. So currently we have 18 millimeters center to center, right? And I'm sure the Bowden cable will eat up a little bit of travel. The slack everywhere will eat up distance. No, it's 21 center actually. So right now we have 21. We should reduce it a little bit. Maybe 15. 15 would be better. But we have different. We can try to go 50 on this distance. Just make it tighter. Then it would be faster actually. If we make it even tighter, then we have to lower this accordingly. 12. Let's check this. The part is getting smaller and smaller, Hannes. Do you know how happy that makes me?
Soon it will be gone.
I wish. I actually wished. Soon it will be gone. What a brilliant song that is. Right?
It's simply marvelous.
Look, we're still on 30? I thought that would... Am I thinking wrong here? Oh no, the degrees gets more, but the distance gets less. Is that it? So here we were on 21 before, and we're now on 20.9. It's not doing a whole lot for us. Moving the thing up would probably make more sense then. It's funny that I'm doing this in that I'm not checking in the sketch. I should just check in the sketch. So let's put the pivot point here. And then I can just copy this. Wait. I want you and you. Copy. Paste. So now I'm doing the same test by rotating these two items until the little, you see the little dot there? It needs to go over the line there. Interesting though that this is pulling like down now. Why is that? So here we are on a 12 travel distance. So way less. But will the music be less tight if we do it slower? I think so. The faster things opens, the better.
You know what, Martin? Time for a little hydration break, and I will put this up here. Craig Dean asked me in chat to show you because he thinks this is relevant for today's topic. Can you read it? You see it?
Yeah, it's great. Thanks for using the template. The height needs to be adjustable manually and using a cam to raise for mute. That's a half hit again, because when you're going up and down, right when the pin hits it, you're gonna get half hits. So that doesn't work. It's the half hit issue again. Height needs to be adjustable anyway. I don't think so. It's better to tune the baud cable pull length by choosing the point. As the height needs to be adjustable, then implementing mute by raising the detector becomes trivial too. Making the height raise adjustable is required to above constraint. Muted channels do not add to force required to rotate programming. You're right about that. And overall system noise is reduced as muting occurs at earliest point in chain. You're right about that. Reducing force here allows more. Where you would like to use multiple programs to instead play fast notes. So another thing, when you then put it down again, you have no way of avoiding the edge case where you try to put it straight down on top of a programming pin. And that will just break the system. So then you need to kind of have a spring that allows for that. So a lot of good points, but it just comes down to the fact that taking the registrators in and out of the programming pin, sideways or upwards, has just never been solved. It doesn't work. But I love the thinking, and you're absolutely right about reducing the noise and stuff like that. Unfortunately, we can't do it.
It's all about a half hits, baby.
Yeah, it's
It's all about the dum dum da da dum dum.
It's I've been there a lot of times where I like, oh, that would be so nice, and I'm like, oh no, it just does not work.
It needs to be insanely fast for it to work, right? It needs to get out of the way immediately.
You said something there actually, because if it's faster, like than the programming pin moves, and then on the way down you have a spring, so it doesn't hook on the top of a programming pin.
It could work, but I feel it's perhaps hard to make it secure.
You heard it. Sir 3K, you think it's too complicated.
But it could work, you know. But this was mainly for muting, and muting was one of the few problems we didn't have on the MMX.
Yep. So what I'm thinking about now, or should we just move it even closer? I'm slow because it feels like we're solving something, and then I'm like just cozying up with the CAD. It's a little stupid. I should actually try to execute this pretty soon.
Kalle Liljeholm, in the words of Farbror Barbro, there are no shortcuts to the perfect sound.
That's some brilliant Nile City right there. Some inside Swedish baseball. It was one of the best TV series ever done in Sweden.
Yeah.
Fantastic stuff. Let me see this shorter thing. So my what I'm thinking here is that a longer travel distance means that we have more speed of the thing moving, which is more musical accuracy. And I'm thinking we can eat up the travel over here. And then we get better, so it always hooks. So what I mean is that we can make this gap longer here. So let's do 8. So the thing is actually moving in 8 millimeter air first, like this. And then it just hooks it on the end, which means that we know that it's always clearing. Because on the first machine, I was like, oh no, we can't have a gap. That means that the music is not tight. But then I realized, no, it just means that the note is coming when the red thing is interacting with the yellow. And if we allow for this, this would be a pretty nice... If we have done something wrong in the construction, we can just manufacture this part or this part again to kind of adjust for travel length. And then the speed of this is more instantaneous, which opens up this arm on the marble gate faster, which is exactly what I want. So I start to think that maybe we have something here, just the way it's looking right now. I want to move down the bolt a little bit. Let's do that.
You know what? I need to bolt.
Oh.
To the Wiz Palace.
Oh.
Be right back.
Absolutely. Let's do 4 here. That should move the bolt. Yes, nice. Sketch is working. Oh, now the fillets are working too. I should probably fillet this edge as well. Oh, we can have this touching the roof here. There's no... That would add stability, actually. That's a good idea. So right now, you see I have a gap there. And there's no need for that. It will add just stability. So let's fix that. So we're gonna say, we're gonna remove this constraint. You see this line turned blue, and I'm gonna say that you are collinear with you. This is pretty cool. I like this. You can see how it's like clamped into place. Let's reduce fillet. Oh, love this. All of a sudden it brings more stability, kind of. I have a feeling we should color this part for some reason. Here we go, blue. And now And that should be kind of it. So let's add the positive stops. We do not have that function right now. So first of all, we want it to rest in this position. So do we want it on the front here? Or do we want it on the top? Maybe it's nice for us to be able to access like this connection point and to see things. So let's think first of all, where we want a spring on this thing. Maybe the spring can... Yeah, so probably on the top here somewhere.
I leave the room for a couple of minutes and Sagan asks, look at car throttle body to change the hit response. The shape of the cam, the Bowden cable links to changes the speed at which it is pulled.
Car throttle body. Interesting. Thank you, Sagan. Thanks for the support. Can you check that up, Sir 3K?
Car throttle body. I'm the worst Googler when it comes to this.
No. You can do it. I believe in you.
Images.
So let's add a stop here. I'm just gonna start somewhere.
This is a car throttle body at least.
To change the hit response, the shape of the cam, the Bowden cable links to changes the speed at which.
Is it like...
I guess you mean
what's in here?
the distance of the hit point. If I understand it correctly.
Let's see if chat has more on that. Steelskin 667, that's a good point. Car throttles did use to use Bowden cables at some point.
Okay, so if more people are interested in it, if someone can like pinpoint exactly the function, because it was a little hard to understand from the Googling results there.
You'd be better off searching throttle cable cam.
Oh, that's helpful. That's really helpful. This is my first idea for a positive stop. We do this, and we do that. That looked awful. And we need 2 curves.
Okay, here we at least see some cables and stuff around here.
I have a suspicion that this is making something adjustable that we don't need adjustable, but it might be just that I haven't understood it yet. Look, it has a little horn.
Sagan, the shape is not round, so the radius increase as you pull.
I understand, but to what part is it relating? Is it to the pins on this thing? Do you mean that this area should not be flat? I'm a little confused on
eccentric pulley. Mm-hmm.
Yeah, so please try to give us as much context as you can, because we are not reading the mind so well, and also when you work on other things. So like, do it always for dummies, like this thing there because of this thing there, like write out the whole thing, then I might understand better.
Mr. B. Fox, 1775. It is eccentric, so speed of pull increases as it pulls more.
Okay.
So the speed of it.
Yeah. So, but where does it relate to the registrator? And it's what I'm not getting.
Shouldn't it be on the way back? Or am I stupid?
Either you or me or both.
Or all of the above.
I'm gonna find a place to add a spring. Ooh, maybe this is a very simple way to add a spring. Wait. That would also maybe look cool. I'm gonna see if we think of.
Okay, so Sagan is saying you want the gate to open as fast as possible. So that's the solution is to have it to open as fast as possible.
You're on the gate side of things right now.
Yes.
Now I think I see where you're going. It will require a lot of force, and I think I see where you're going now. I think what you're suggesting is to move this pivot much closer to the top pivot. But I think the cost you pay for opening the gate faster is more resistance because it's like a gear. I think I understand where you're going with it now. Are we having... Oh, we're already having double... Okay. I just had a little Christmas Eve here now. Because we already have double machining. What are you laughing?
I love you so much, Martin. Makes me so happy.
Back at you. Sir 3K. No, it's a little Christmas Eve sometimes when you're realizing that you can afford a double-sided machining operation. Like you've been here feeling poor with only one-sided machining operations, and all of a sudden, the birds from Cinderella have made the dress, you know?
Oh.
I always cry. Yeah. I always have a hoodie on Christmas Eve so my family don't see me crying to Cinderella. It's funny because it's true. Because when the birds make the dress, it's just so like they made it, you know, because they wanted her to go to the ball.
Oh.
She never have fun.
Oh, and the mice. Ha den äran!
Oh wow, spot on. She never have fun normally, Hannes.
No, we all just want to go to the ball.
This is going to be so beautiful. Check this out.
This is your dress for the ball you're designing right now.
Yeah, and you're the birds.
Chat is the birds.
Chat is the bird. You're that mouse who says, ha den äran.
I'm the mouse.
So, are you ready to get your mind blown?
I'm ready.
Are you ready to get...
Oh, I'm ready.
Or are you ready to get a spring attachment point? In this case, it's the same. Look at that. Isn't that little lovely little friend? Right there. Right?
Gonzo opening up here as well. It's Frozen that gets me. Let it go.
I love this. I love this so much. Gonna show you where I am going with
This
this.
is lovely. Funkopotamus Wes just popped in to say I love you guys. I never get to catch the live streams due to my busy schedule as a music ed major.
Oh, cool.
But I have learned so much from you guys. Thank you and best of luck. Right back at ya.
Funkopotamus Wes.
Love you as well and good luck.
Yeah.
That sounds amazing.
With the music major. It's really cool. So here's my idea.
Philippe Boisdin. Boisdon? We all just want to go to the ball. Put that on a t-shirt. Next merch idea.
Nice. I'm just gonna take a spring here. Extension spring with loop ends. Let's take a 40mm long spring. 3D step download. Where are you, my little spring? Do 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 do. Oh, it's a little bit big. It doesn't matter. It's just to get everyone on board with what I am doing. It's always nice, I think, because this will expose the springs. And I think that's going to look nice. It's my idea, anyway. So now we need a stop. Let's sketch a stop, the positive stop side. So, and here's my Achilles heel in all design. Do you know what it is, Hannes?
No.
Like foam and rubber materials. I want something a little silent here. And it's always so tricky. So this little pad I'm making here is a foam pad. Let's say it's 5mm. And it's 10. But that's attached to something big and chunky.
A lot of suggestions is popping up on Dropbox, which is a good time tomorrow then to do a real design review where we dig deep into the folders, right?
Definitely.
Yeah.
Definitely.
Friday fun day, you know.
If you have something related to exactly what we're doing, I would love to see it now as well. So new component, foam pad. So just to explain, like we can pull this out long because it's gonna be the same pad for all of them. But right now I'm just doing it for this channel. 16. So here's a silencing foam pad, and it's so close to the pivot. This should be pretty silent, actually. Foam pad, new component. Positive, stop, and spring holder. Here's a tricky question for everyone. Should I make the spring tension adjustable individually or not? Oh, there's these pins. Oh, there is a cool pin. Sometimes when I make spring adjustable, it's just because I didn't put the time to find the correct spring. But also, it's always nice. We'll see. It's a later decision. Let's pretend that's a plywood part. Maybe not. I don't even know if it's going to be a single plywood part. Yeah, the gears. And the felt is green like in a pool table felt.
Let's start
Foam.
watching a little nice video appeared here on Dropbox. Let's
Ooh.
take a little look at that. It's
Love
called
those.
Muting Mechanism with Double Channel 1 Dropper Disconnect. Just gonna put that on here and see what's happening.
Aha! It was just solving the problem from this stream. To use AB program to repeat faster with two registrators. That is super creative. And I love how you animated it by pulling the parts around with the mouse. That's brilliant. Cool. Who's this from?
This is from Leonardo.
Leonardo
The
da
coolest
Vinci.
turtle.
Leonardo da Vinci.
My favorite turtle as a child.
Yeah, Donatello for me all the way through. Brilliant. Brilliant video.
Cool, huh?
Fantastic idea.
And I will queue up. We have a lot more.
I don't think it would be possible in real life, because I don't think we have the travel length needed, and when the tension is on, to then separate them. I don't like to slide them, force them apart during the tension, but it was very, very creative solution. So here's the spring and the stopper. Let me just double check so we're not running into the stopper when it's pivoting. I need this, and I need the tip. Where is the tip? I don't know if the rain is going into the mics. Oh, look at this.
I hope so.
It's perfect. It doesn't hit the roof there. And then it will return to the foam pad with the spring. Huh. I love it.
A beautiful chime. From Moonquake. Avoid putting adjustability everywhere. Design with adjustability in mind, but do not implement it. Wait until the need is proven.
Okay, so that's a good... Thank you, Moonquake. That's input on my spring adjustability thing. And I think... Yes. You're right. I mean, you can have... Adjustability everywhere is just... You're basically too afraid of making decisions then. Like, we leave everything up to later. So, with your comment, and thank you for the support as well, I'm going to actually I'm going to mount these springs without adjustability. And we just have to find the correct spring. Because I know on McMaster Car, you saw them. They have 31.1, 31.2, 31.3. I think it's for this reason, because they know, like, yeah, people want to buy like the next strongest spring. So clean also.
So let's take a look at some more suggestions. And here is the angle we want. This is from Dan Segalov.
Quick return. Oh, it's solving the same problem. Quick return registrator for 2-channel operation of 1 marble gate. I think it's the exact same idea. Oh, it's in a roller guide. So greatly speed up the reset time. Registrator operates just like current designs, except horizontal rod is guided along a roller guide. Hang on. I'm just looking over here because for the rod to mute, it has to fall down. And also when you unmute, a registrator is triggered, the guide controls the direction of travel while still being triggered the roll guide. Yeah, so I think where this is not working, if we go to CAD, is that when in the edge case, where a note has been played, when we demute, this has to be able to separate. They have to be able to go apart. And if one of them is controlled, so when they come together, they have to be able to do this. And if one of them is controlled by height all the time, I think you can't push it open. I think that's why it's not working. But cool suggestion. I'm basically leaving the idea of trying to trigger. I don't think I'm pursuing the idea. I think I'm going for the simpler, to not even have it at all. Yes, adjustment screw there.
Space noodles.
I thought of this before. It's very good. It's a very good suggestion. Why did I not like it when I thought of it? Because if we have that much travel, this is very interesting, I feel.
Something to marinate on.
Definitely. Thank you for sending in the suggestion. What if instead of having a lever force to move the pins, you had a horizontal force? Mini quant. This could go to your current half hit prevention design. So I think you're moving the force. You're moving the force 90 degrees. I think that. If I understand it correctly, I think that's kind of it's a little complicated to move the force 90 degrees. Yeah. Thanks for the suggestion.
It's just a little image sketch here.
That's moving the... Okay, cool. Gear as registrator. So... Yeah, it's more complicated. More pivots, more things. But it was nice to see an image of it.
I will just quickly also show a short little video. That was smooth programming wheel.
Meanwhile, I realized that I could make this a little bit better by doing this. So I'm extending the front here so the thing is clamped at all positions.
Oh, wait. Maybe if I do this instead. Can you see this? A smooth wheel. There's some accompanying text to this later as well.
This is how I want to do the open hi-hat stuff. This is the cam shaft wheel idea. So I want to use this for open hi-hat. I want to use it for super fun to see. I want to use it for the sustain pedal of the vibraphone. Stuff like that.
So let's see. There's an accompanying text with this. I just need to center it.
Look at this. This is starting. This is this is actually turning kind of great.
Smooth programming wheel. So my idea is that instead of having pins moving the registrator, you can just have a smooth surface that the registrator is always in contact with. It eliminates the edge case of the registrator hitting the top of a pin. With this, you can also have very fast notes. It doesn't show in the video, but there should be a wheel at the end so that the registrator doesn't scrape off the programming wave.
It's very outside the box. It's very very challenging because there might be more to it than first meets the eye. It's very far from what we had before. It's interesting though. Look at this. This is clamped here, Hannes, the blue parts. You see how nice it's tucked in there? It's just having a nice time in there.
So here we have also John Loves the Lord is back today. Hannes 3K, please steer Martin toward felt instead of foam.
Yeah, so felt is an organic material and it shrinks with like it getting packed, and it shrinks with moisture and stuff. So tell me why, because
Felt block over wood is proven tech off the shelf. And also Philippe Baudouin, warning, it will hit the roof if you adjust the registrator distance. And also Mr. B Fox, if adjusted it will hit roof? Question mark.
Yeah, that's true. We're going to make more clear, good one. Let's lower this shoulder here. Gretzky's in the chat, skating where the puck is going. That's very nice, pointed out. Let's lower this.
Chimes. Cleo Poilin. Gear as registrator may be less parts. All those pivots are on a single axle compared to setting all those springs. Also, it is quieter.
Thank you so much for the support. I think I disagree though, because I still didn't see how the gear teeth is pushing. So why is it quieter? And how do we get it to? How do you get the gear to stay? So it's being pushed. How to get it to stay there? What prevents the gear from just sliding around back and forwards? How do you get it to push a rod, skip the rod, and then the next teeth pushing that rod? You added a whole other pivot. I'm seeing a lot of dark clouds on that horizon. but I love when you're championing stuff, but I'm not seeing it currently.
Killian Ruckty, Hannes, the spring will be blocked by the foam holder when the registrator pivots.
Yeah, true.
True.
We have to give more clearance.
John Loves the Lord says piano felt. And also Yoshik V. Tumane says that felt works on pianos. John Loves the Lord. Felt instead of foam for registrator arm stops holds shape better over use and known dB reduction.
Have you heard the keys of a piano? It's dunk 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 in the whole thing. Foam. I'm using foam very like the thing when you go camping that you sit on when to be warm, or you sleep on. Like that kind of some kind of PME something. I have it some over here. I think it's superior over felt all the days in the week.
Did you get scared of felt when you used it while you were welding on MMX when it always caught fire?
Also felt is like If you glue felt on, the glue will seep into the felt and make the whole felt hard. And where if you glue like foam on with the correct glue, it will stay on the surface and not penetrate into the foam, and the foam will stay squishy.
Mm-hmm.
It's another kind of thing. I have an idea here that we're gonna use CNC with the spring tension here. Let's see.
Is this what it's called from Makoloco? Bitumen foam?
Yeah, I don't know. Foams are there are so like
so many foams.
there's so many foams. Why can't I change this? What constraint am I missing? What is happening here? So when I say foam, I'm using it a little bit too loosely. 30 was okay, apparently.
13 Peeps says if you use foam, you have to make sure it's replaceable because foam will not last.
Okay, so some discussions we're having is when we don't agree about the word. When I say foam, I think you think of like the thing in like cheap mattresses. I mean like engineering squishy plastic.
Like Mr. Gonsonator says, neoprene. That sounds cool.
Exactly. So I think like this discussion is maybe more about like
semantics.
There you go, Sir 3K. There you go, Sir 3K. So if that's the foam you mean, then I agree that felt is superior. But I mean like I mean something else, I think.
And Mike Perry says, I think that you might be talking about open cell foam. This is the soft squishy foam that you might use in audio dampening in a studio. Not exactly sure, but that might put you in the ballpark.
Yeah, that's what we should not use is the feeling. Oh, my beautiful part is getting so long all of a sudden. Not good. But I think it needs to. So here's my idea. This is a square tubing with CNC cut holes for the spring holders from 24/7 steel. Minus how much? -4 is the wall thickness, let's say. And let's make the foam part 8 millimeters. So it's interesting actually. When we wrote the design requirements, people started to talk about like that we have to have a common language. And I think a lot of the discussions when we disagree on stuff is that we're actually talking about different things. And I think that's the same for most internet conflicts as well, which is kind of interesting. When people are at each other's throat online, it's kind of always because they are having different definitions of what they're talking about. I think. My small part is not so small anymore.
Tell us in centimeters how big that is, though.
Okay, you're right. You're on the ball with that because it's probably very, very short. It's like 10 centimeters.
Ow! Auga! Speaking of auga, we have a true all-star joining in. I think we have a little theme on the piano. Slice of Sparta is here. Y'all are trying to escape me with these early streams, but I have too much H3K positivity to be stopped. Love seeing these designs refined. I agree with simplifying the marble gates. Cheers. Woo!
Nice to hear from you, Slice of Sparta, and thanks for the relentless support.
The relentless support.
Yeah, it's very appreciated.
And yeah, I felt there was something missing from the day, and now it feels so complete. Slice is here. Woo!
This spring is way too big. This is okay. I extruded these in the wrong ways. But regarding like semantics, when we're talking about different things, I should do a better job when I just throw out a word like foam. I should like, it's actually I put most responsibility on myself because I should do a better job in trying to like communicate what I mean as good as I can. And I think it's very interesting, like because we know in our heads what we mean, but sadly, it doesn't always translate to the other person's head. Have you experienced that sometime, Hannes?
Never. I am crystal clear with everything all the time.
Okay.
Yeah. No one can misunderstand me.
Well.
Well
Well done. I think this might be a pretty efficient design. Check this out. So this is the square tubing. And then we can have the holes CNC cut, and think of this as a long square tubing. And then they can cut, we're going to capture this position. They can cut these holes. So let's make a sketch here. We can cut holes here. For what kind of bolts do we want? M4. So for M4 bolts, boom, boom, boom. Boom, boom, boom. I think they can cut 4mm holes anyway. And let's just give this a measurement. 6, 7. I have to find a smaller spring. So what they can do 24/7 steel is that they can like pull this square tubing in a rotary CNC and laser cut and turn it around. So they can pre-drill these holes in the square tubing, and we could then add something that the spring is just attached to. So simplest of all would be like an M4 bolt. So let's insert that. Do I have a hardware folder? Let's create a hardware folder. M4 bolt, no, hardware.
And we get some more foam tips in chat. And someone mentioned EVA foam. And that's often used in like cosplaying and stuff. And I googled, and yeah, that looks promising. EVA foam.
Oh, can you show me a picture?
Oh, I have some. Here we have some. Look at this one.
That's probably a little bit hard.
Look at that. Mass Effect. Here we go.
Of course you. Sir 3K is like
Halo. Here we go.
If you can do Halo costumes with it, it must be the best
It
foam.
must be the best. But if you look at it, it's let's go back here.
Yeah, stuff like this.
Easy to laser cut, someone said also.
Yeah, stuff like this.
Yeah, EVA foam.
Yeah.
So thank you, Pancake Legend.
There's a whole wide world out there.
And Slice of Sparta also said that neoprene is what fancy life jackets are made of, if nobody has said that yet.
Oh, cool. Here's my little bolt. And I'm going to just add this to the underside of here. So here I'm thinking design for manufacturing, my friends. I'm thinking I'm ordering this square tubing drilled like this, and I'm ordering standard bolts, and I'm attaching them with a nut. No threading of the metal. So we're going to add a nut on top as well. And I think that's kind of a super... So this will be a structural element. And if we have space... Oh, I'm excited for this idea. If we have space, we can have brackets Oh, I should actually show this right away. So the registrator pivot is going to be super long. And I don't want a bow in the middle, and I want it kind of thin, because then it pivots easier. Supporting brackets. So we can choose points along the edge, and maybe some seam in the programming wheel, perhaps, where we do supporting bracket that goes from the square tubing. Start a sketch here. And just holds the axle and the shaft. What is it called? So let's say it's like this. It's going to be a stupid thing now. I just want to show you the idea. Boom, boom. Boom, boom. So it will look like this. So that this could be, for example, a 4mm metal bar. And this would kind of hold, make sure that the long axle rod is not bowing, because we have the added support from this super solid square tubing, and they kind of help each other to create a chunky thing. But this requires that there's a pause in the tracks. Maybe we don't want that. We'll see. I just wanted to show you the idea.
Yet again, we come so a long way today when I just look at this part right now. Process is being made daily here. Oh my god.
It's fun to be in CAD again, actually.
Yeah.
Ba-ba-boom.
I mean, I sit next to you and something clicked for me yesterday when I saw the parts in CAD. Stuff you've been talking about for weeks. It's easier for me when I see them.
Yeah. It's
so abstract.
Yeah.
So that's why I think so many people connected with the video yesterday on the main channel. Like, okay, now we understand what you're doing. And it's going to be a lot more where that came from when the prototyping and everything will start.
That is going to be so fun.
Yeah, that's going to be fun.
If we're going to do this project. What's that? What's that? Have I really deserved that kind of treatment?
I was on a high and you just shot me down.
Yeah, but there's just too much hopium.
Right.
Hope is not a strategy.
Yeah, maybe I should just leave.
Wait, why am I just not? Of course you should not leave. I should just make maybe this is overkill. We should make like a steel. Too much hardware here. We should just cut a steel thing that welds on top. Oh, with holes in. With holes in, Sir 3K.
Let's see here. Mr. Gonznator, my 2 cents just dropped in the Dropbox. So, let's have a quick look-see there from Gonzo.
Right angled rolling registrator. Movement is pivoted here. Roller is pushed. Timing edge. Too slow, I think. And the pins are a little convoluted, or what do you say?
I don't know, but I know what to say now. Chimes, the beautiful chimes. And this comes from J. David Whitfield. Perhaps a cotter or clevis pin instead of a bolt?
Yes, so the clevis pins would stick right in, and I learned the clever spins another day. It's the one with the little little grooves, right?
Ooh,
Oh,
they're so
there.
nice.
Oh, they're beautiful. Can I zoom in on them? But I have something simpler. We're going to cut 2 steel profiles and not have all these.
A cutter or clever spin. Well, thank you so much for your suggestion and your support. It means the world to us.
Definitely. Thank you so much, David. J. David. I'm thinking instead of all these loose parts, yeah. So screw these holes.
Screw them.
Yeah. Expensive, I think, to drill all those holes. Instead, let's just make simplest thing in the world. New component. Spring attachment profile plate. And it's just welded onto the backside of this friend. And it looks like this. It's the simplest thing in the world. It has a nice little hole there. 4 millimeters. And then it has a nice little rectangle like this.
Rectangular pattern. Be careful, my friend.
No rectangular patterns here. So... And this is yet another 24/7 steel part. They are cheap and reliable. Boom. Just like this. Doesn't have to be harder than that.
Ba-ba-boo.
And it will also actually add some strength to this tubing thing.
That's brilliant.
Simple, right?
Yeah.
Because there are springs where the eyelets are in 45 degrees. And then the spring will just love to sit from this hole here to there. Let me make a coil instead of this spring. I'm going to delete the spring. Delete. And we're just going to make a coil. Spring.
And I hate to be that guy, but we're slowly coming towards the end of our stream, Martin.
Okay, cool. I am feeling actually that we did a lot in a way on our cozy little autumn stream feeling here. I'm gonna fix this spring and then I'm gonna wrap up and give the big picture.
Yeah.
20 perhaps. Section 7.
Some guy says it's the simplest thing in the world. Martin talking about his marble machine.
That's funny. If I pull this out, boom.
Oh.
20.
Shh. Did I hear something? Oh, I did! Chimes. And it's our friend Moonquake again. Pin should activate the registrator axially. You could have slowly rising edge of pin, raise registrator and charge spring. Abrupt falling edge causes registrator to fall and drop marble at the exact time.
Pin should registrator actually you could have slowly rising edge of pin, raise registrator and charge spring. Abrupt falling edge causes registrator to fall. So thank you so much, Moonquake, for the suggestion. It's super hard to picture And thank you so much for the support. This is like, again, like like if you can make a sketch, it would be fantastic.
You're the best, Moonquake.
Because you might have a great point in there, and I would hate to miss it. But it's not clear in my head what is being referred to. Let's see here, 8. How beautiful is this?
Almost as beautiful as you.
Wow.
Which is saying a lot.
The outpouring. That's one of my favorite Harry Potter lines when Dumbledore says in the first film, like hiding the stone in the mirror is actually one of my brightest ideas, which coming from me is actually saying something.
Moonquake, I sure will. So, okay.
Thank you,
sketch
Moonquake.
is coming up.
Thank you so much.
And hopefully we'll take a look at it tomorrow when we do a design review.
So check this out. I just want to show you, I can't end this without doing a rectangular pattern. So I should be able to just look.
Okay.
Boom.
People are actually really excited by the idea by Moonquake.
Okay.
People are some, like Freddy Cantu's falling edge versus rising edge activation is actually really smart.
I would love to see that Moonquake.
Yeah.
Because I'm not following right now. But what I am following is the epicness of the look that will soon haunt your eyes.
Bless your eyes.
Now haunt them. Oh no, it went wrong. Soon. Let's not choose extent and let's not choose faces. Let's choose bodies. Ooh. Let's cancel this because this didn't go well. So I asked Fusion to copy everything 30 times and then understandably it slows down. Let's do this from the beginning. Rectangular pattern, type, components, all those, directions, select, spacing, this way. 16 millimeters, 37. So this is all one big part here with all these holes. And you can see all the springs are just like a...
Oh.
That's nice, right? So nice.
It's starting to look like a cozy bed.
And you know what? When I need to adjust the channel, I have all the screws right here.
Oh, and right now it's a Freddy Krueger pattern here. It's like on his sweater.
Okay, with the red and the green.
Yeah, I like this. Let's add some kinetic fingers with knives on the fingers.
And you know, since this thing isn't going to be detachable, this big square wing is going to be welded to the frame on the side. So no attachment with screws, welded to the main frame. And I absolutely love it. I love it. It's I'm very excited about this, and I love hearing all your ideas, and I love that you're keeping us company while we're trying to evaluate if the idea of Marble Machine 3 is feasible.
And the idea is better than ever right now. Woohoo!
I am totally gonna go like anti-hype. So it's...
You can't stop me, bro.
No, I realize.
Okay, everyone. It's been a pure delight sitting here in front of you. And you're bringing us those awesome suggestions and beautiful comments. You are truly, truly amazing. We love you all. Take care, and we see you on the next one.